Hello students, welcome to today's session on heat, temperature and expansion from the very different and very modern unit of calorimetry. One of the highest scoring and highest weighing units in CBSE boards and other exams too, and kind of a bonus unit of 2 to 3 chapters which you can assume to be. Yes. So what do you mean by hotness or coldness of a substance is basically heat. So measure of any body, measure of any atmosphere relatively to be at higher temperature or to be at a lower temperature is what you measure that to be as a hot or a cold substance. The first point, the two bodies A and B are at two different temperatures, T1 and T2, which are put into direct contact. Okay. Now, if T1 was greater than T2, means the temperature of a body was greater than the temperature of the second body, some temperature will flow from A and to B. No, it's false. In the second statement, some heat will flow from A to B. Yes, that's true. Now that's what you call to be as heat. The first unit which we are describing, the first physical quantity, which is heat. Temperature is not flowing, but the hotness is flowing along the concentration gradient, yeah, along the heat gradient, you can say. That means from the higher concentration to the region of lower concentration. You can always assume an ice cube and a heat rod. A heating rod and an ice cube, both at their respective temperatures, means at a very higher temperature and a very lower temperature. You will never find the heating rod to get cold, but rather you will find the heat getting transferred from that particular heating rod to the ice. That means the ice melting. That what does that phenomena explain? That phenomena explains us that heat follows the concentration gradient. That means from the higher concentration to the lower concentration. Higher concentration of hotness to lower concentration of hotness. Heat cannot be stored. That's the reason it's flowing. It can flow from A to B. The exception to this is a thermos flask, where we are not allowing the heat to flow actually by thermally insulating it. Then the last topic which we have, the introductory one, is the thermal expansion. The three expansions, linear, areal, and volume expansions, are nothing but they are relative changes in terms of length, area, and volume, whose expressions will be derived in my upcoming classes. And the most important expressions are on your screen for this unit. L2 is equal to L naught. That means the final length will be initial times of length times A1 plus alpha delta theta, where alpha is the gradient change, coefficient of linear expansion. Yes. Then delta A is equal to A naught beta times delta theta, where beta is the coefficient of, could be, areal expansion. Yes, there it was linear, here it is areal. Then you have gamma, which is volume expansion. So three different terms, three different units. Then volume expansion, delta V is equal to V naught gamma times delta theta, where V2, that means the final volume, is equals to V naught times 1 plus gamma delta theta. Yeah. Certain important relations where we are considering bulk modulus and thermal coefficient of volume expansion. Also, the derivation of these three, L2 is equal to L naught, A2 is equal to A naught, and V2 is equal to V naught, will be done in my upcoming classes, as I have henceforth told. Bulk modulus and thermal coefficient of volume expansion, where delta P is equal to beta times delta V by V. This relation is also very important when you're doing the dimensional analysis of bulk modulus. So beta is basically, B here is the bulk modulus of elasticity. And then these three are the relations, alpha, beta, gamma. And in the denominator units, you have 1, 2, and 3, just to learn and just to cause a relativity, condensifying our content. So such will be the backdrop of my classes. Thank you so much, students, for joining me. Keep practicing. And if you have any queries, please revert to my Urban Pro profile. Thank you so much.